a number for calories?
425.45.
Everybody got that?
Yeah.
Unit?
K-cal for 40 minutes and 75% VO2 max.
Okay, do you guys want me to write this out? Okay. So, common error here would be to use the 48 to calculate energy expenditure instead of the 36. I guarantee you she's not working at the 48 for 40 minutes. You can't work at your VO2 max for 40 minutes. You can work at 75% of your VO2 max for 40 minutes. So make sure you use the submax. MLs, kg, unit.
Will you always provide a submax if needed? Like for the.
Well, no, in this case I didn't provide a submax. I gave you a max and told you what percentage I want them at.
Oh, sorry.
So you had to calculate
You'll
that.
always give us the percentage of this.
Yeah, I give you the percentage. Okay, can someone tell me what these kilograms are?
59.09.
59.09
Yeah.
Yeah.
kilograms. 5 calories per liter and 40 minutes. Okay, that's the setup. I'm assuming it comes out to 425. Questions on that? Okay, so Gabby's my client this time. I tested her VO2 max at 48. Told her to train. I want her to train at 75% of that, so I told her to go on the treadmill and run 6.1 miles per hour. So she's going to come to me and she's going to say, but coach, it's a really beautiful day. I really don't want to be on the treadmill. I'd rather go outside. So the problem with going outside is that how do we make sure she stays at 6.1 miles per hour? We can't. So in that case, we use heart rate. So if I know what percent of her VO2 max I want her at, I can calculate what percent of her heart rate max I want her at, and then I can tell her to stay at a certain heart rate, which will put her at that intensity. But it's not equivalent. 75% of VO2 max is not the same as 75% of heart rate max. You have to do a conversion. So there's a formula for that. Yes.
Is that what a lot of cross-country runners do? Since they can't really track their speed.
Train by heart rate. Yeah, or train by time. Yeah.
Yeah, I assume it's by time.
Okay, so first thing we need to do, it's going to be percent of heart rate max. So we need to first figure out her heart rate max. Okay, let's say she's 21 years old. Do you guys know how to calculate heart rate max? So you should have learned it in lab.
That's hilarious.
It's, okay, heart rate max, here's the formula. 208 minus 70% of your age. So if she's 21 years old, we're just going to plug in 21 there, multiply it by 0.7, subtract it from 208.
Sorry, the 208 was.
This is a given formula.
Given.
Yeah.
Okay, so it's always going to be 208.
Yes,
times
you need to
the
memorize
minus-
this formula. I expect that you guys know this. I will not give it to you. Go ahead.
The 208 is just the way they found that out, right? It's just because the heart has a refractory period that like it could continue conducting more heat, but at that point it can no longer pass that, right? It's anatomically impossible to pass that at your heart.
I mean, it's not impossible. This is average max heart.
Oh,
Yeah, it's actually got a plus or minus 10 error, but it's the best we can do. It used to be 220 minus your age, and then this is supposed to be a little more accurate. Okay, what did we get for this? 193.3. Did everybody get that? Okay, I'm not concerned with counting a third of a heartbeat. So, 193. What's the unit on this? Okay, so this is heart rate max. This is the highest. This is my estimate of the highest her heart rate can go. I'm going to want to put her at a percentage of that, but I need to figure out what percentage. Okay, so just to get you credit, I'm not ready to erase that. So this is the Swain.
Oh, you grabbed the bad
Swain formula. heart rate max equals 0.6. Yes. 0.64 times percent VO2 max plus 37. So, if you know what percent VO2 max you want them at, you plug that in there and you figure out what percent of their heart rate max you want them at.
Will
Yes.
this formula?
This formula will be given. Okay, so for this particular formula, when you're plugging in the VO2 max, you don't put it in as a decimal, you put it in as a whole number. It's just how the formula was developed. So if I want her at, what did I say, 75% VO2 max, I'm gonna plug in a 75 there. Times 0.64 plus 37. Please tell me what I get. Exactly?
Yes.
Okay, did everybody get that? Okay, am I done? Is this the heart rate? Just beats per minute?
No.
No, so if you're not paying attention to what you're doing, you might think you're done and circle this as your answer. Okay, but if you understand conceptually what you're doing, there's no way I'm gonna send her out to work out with a heart rate of 85 beats per minute. That's way too low. Okay, so what is this 85? This is what percent of her heart rate max I want her at. What's her heart rate max? I'm gonna take 85% of it.
164.05.
164.05. Okay, I'm not concerned about 0.05 of a heartbeat. Okay, so now Gabby wants to go outside. I say, okay, you can go do your run outside. Try to keep your heart rate as close to 164 beats per minute as possible, because that's going to put you at 85% of your max heart rate, which is approximately equivalent to 75% of your VO2 max, which is where I want you. Phenomenal tool. Okay, so what this will look like on here is I'll have a number 3 that says, what would you expect her heart rate to be? Okay, I didn't ask you what percent of her heart rate max you want her at. I didn't ask you what her heart rate max is, but you need to know that you need to go through those steps to answer this question. Okay, hold on one second. So there's a lot of math going on here. So very important to keep your numbers clear and organized and labeled and with units. Okay, make sure you understand the difference between the max VO2 and the sub-max VO2, which one to use when to use the running formula, when to use the Swain formula, when to use the energy expenditure calculation, when to use the heart rate max formula. There's a lot going on, okay? The running formula and the Swain formula I will give you. The heart rate max formula I will not give you. The ladder I will not give you. The 2.2 I will not give you to convert pounds and kilograms. But the 26.8 I will give you with that formula. Okay? This is the type of question you can expect on the test. So please, if you're struggling with this, work with your friends, get with the PLFs, and do lots of practice questions. Yes?
Sorry, you said the 1 mile per hour per 26.8.
I'll give that to you.
You'll give that to
Yeah.
us, but the 2.2.
The 2.2 I will not give you.
Okay.
And the heart rate max I will not give you. Yes?
Okay, so you said in terms of finding your heart rate max and your beats per minute, you want that in a whole number?
Yes. Heartbeats will obviously a whole number. Yeah. Questions? Yes?
So 164 beats per minute is the VO2 max?
No. So beats per minute is the heart rate I want her at. So this is 85% of her max heart rate, which we just figured out is equivalent to 75% of her VO2 max. Okay, so I decided as a trainer, I wanted her at 75% VO2 max. I used this formula to calculate what percent of her heart rate max that is. So I can tell her what to keep her heart rate at. So you can tell by the units. If the units are beats per minute, it's not gonna be an oxygen consumption. It's gonna be a heart rate. Other questions? Okay,
I have one question.
yes.
Can you, so if you were gonna write this as an equation on, or like a question on the exam, how would you word it so that we would know how to? Yeah, but you verbally asked like a few things in between those things, so how many?
So
times-
the only thing I said out loud was, I said it, what would you expect her heart rate to be?
Okay, and
Which would be the
The 164.
Okay.
But there were a lot of steps to get there,
Mhm.
and I didn't ask for those.
So you have to
So-
remember what you're saying. Yeah, you said that.
So if we were to do this on the test, we just like make continue. I was gonna do like big just math equations and just go through it, and then at the end I just like walk one by give you answer for one. or-
So there will be, kind of like on the fat metabolism question that you had on your last test, the way I typically do this is I will have this question and a line here for the answer, this question and a line here for the answer, this question and a line here for the answer. Each answer is worth 2 points. Probably 1 point for the number and 1 point for the unit. Please put units on your answers. And then 15 points for the work.
Yeah.
So I can give you partial credit if you get an answer wrong. That's how I usually do it. Anything else? Okay. This formula, do you remember what the 3.5 represented? Resting oxygen consumption. Okay, so I'm gonna show you something else with that. I'm gonna show you a bunch more things with that now. I'm gonna add another rung to this ladder, which is METs. It stands for metabolic equivalence. 1 MET equals 3.5 milliliters of oxygen per kilogram of body weight per minute. Which means 1 MET is resting. If you're at 2 minutes, what's your oxygen consumption? 7 mLs per kg per minute. How did you get that?
Times 2.
Multiply it by 2. So the number of METs times 3.5 mLs per kg per minute gets you to relative oxygen consumption. So if I tell you you're at 7 METs, how are you going to figure out relative oxygen consumption?
7 times 2.5.
Times 3.5 mLs per kg per minute. Once you do that, you can go all the way up to energy expenditure.
Did you want the answer for that? You were just
So, when you're on a treadmill or any other cardio equipment and it's toggling through its different display options, on some machines, one thing that'll come up is METs. And nobody ever pays attention to it or notices it because nobody knows what it is. But this is what it is. It's just another expression. These are all expressions of exercise intensity, right? We're just changing the unit on it. So that's another expression here. Go ahead.
What does it stand for again?
Metabolic equivalent. So if you have the relative oxygen consumption, and I'm asking you for METs, how would you convert that? Divide by 3.5 mLs per kg per minute, and then the whole unit will cancel out and it'll just be METs.
The one number.
It'll just be, yeah, METs will be the unit. Okay, so I'm throwing this out there because those of you who end up with Andrews for 446, he uses this day 1. So I want you to have at least heard of it before. I typically don't use it a whole lot, but he will, so I want you to have seen it. Okay, go, Jonathan?
Are you ever gonna teach 446 again?
Yeah, I teach you sometimes. When they need me to. It's not up to me. But
Everyone goes.
I'll put a petition down just for you.
so also on your treadmill or whatever your cardio machine is, it gives you, one of the things on your display is calories, right? It's giving you your energy expenditure. it's doing this calculation. This formula is programmed into the machine, so it can calculate your energy expenditure. All it needs is your weight, right? Because you need your weight to get from relative to absolute. And then you can go all the way up to energy expenditure, which is why the machine asks you for your weight when you first get on. So it can do this calculation. If you don't put in your weight and you just skip that and hit start, it's still going to give you an energy expenditure number. It's going to assume that you weigh 150 pounds, because that's considered average. So if you weigh more than 150 pounds, it's underestimating your energy expenditure. If you weigh less than 150 pounds, it's overestimating your energy expenditure. So just put in your weight and it's going to give you a pretty accurate count.
So does that mean that it would be miscalculating the amount of calories that you're burning per hour per exercise?
If you don't put in your weight, yes.
Okay.
If you put in your weight, it's pretty accurate. As long as, caveat to that, if you are holding the handrails. Think about what happens if you get on the scale and you put your hand on the bathroom counter.
Yep.
What happens to the number on the scale? It goes down significantly. So if you are holding the handrails on the treadmill, I guarantee you're not carrying your body weight. So don't hold the hands, don't hold the handles, or the count will be incorrect. I see people all the time walking up a super steep treadmill, but they're holding on. Go
This
ahead.
might be slightly off topic, but would like an Apple Watch that's on your wrist calculate that properly?
So the Apple Watch, you've probably already told it your weight.
Mm-hmm.
It's calculating it by heart rate.
Oh,
So it's doing everything in reverse.
okay.
Go ahead.
How accurate would you say it is?
The Apple Watch?
Yeah.
If you've put in your weight, I mean, I don't think it's horribly inaccurate. I mean, if you watch the heart rate, sometimes the heart rate seems to be right on, and sometimes it seems to be totally off, right? So it's not. I think it's inconsistent. But I think it-
How tight you wear it and all that
Yeah.
good stuff, so you gotta really.
Yeah, I think it's good enough for you to use to monitor your workouts. Yeah. Okay, questions on that? Okay. You thought that was cool. I got way more cool stuff for you.
Hell yeah.
Okay.
I'm like, I can calculate how much you need.
everything.
He's gonna be running around telling people. Who's your weight?
Okay. We
100
said
pounds on the
3.5 mLs per kg per minute is resting oxygen consumption. So I'm going to say that everyone in this room right now, you're sitting in your chair, so we're going to call that resting, even though you might be a little bit stressed after seeing your exam. We're going to call this resting, okay? So I'm going to say everybody in this room is consuming 3.5 mLs per kg per minute. Is it fair for me to apply that to everyone?
Yeah.
Why not? Or did you say yes? It's okay? Does that make it okay or not okay? Okay, so I think we'd all agree that larger people are consuming more total oxygen. Okay, because larger people have more kilograms. So if we were to put everyone's body weight in there, they'd get a different liters per minute number, and whoever has more kilograms is gonna have a higher number of liters per minute. But in relative terms, here, it applies to everyone. Okay, so if we use this as your energy expenditure, so let's say you're in bed and this is your oxygen consumption. Let's say you stay in bed for an entire day, 24 hours.
Oh, that sounds so nice.
Amazing.
How many calories will you burn?
You can figure it out.
Let's say a 150-pound person, because that's considered average, staying in bed for 24 hours. Calculate how many calories they'll burn.
How many hours or how many minutes?
That's what you have to figure out. I'm gonna leave that piece for you guys to figure out.
I'm gonna start to imagine.
Anybody figure out what to put there?
1440,
How'd you figure that out?
you multiply 24 hours by 60 minutes.
Yep. 60 minutes in an hour, 24 hours in a day, 1,440 minutes in a day. So what did you get for energy expenditure?
1718.04.
0.04 unit?
Kcals per day.
Calories in 1,440 minutes, or I'm just gonna say calories in a day. Did everybody get that number? Okay, this means if a 150-pound person stays in bed for 24 hours, they're going to burn about 1,700 calories. That means this is the energy required for this person to sustain life. Just staying in bed requires that amount of calories. So, if this person consumes less than that, that's considered starvation. If you're eating fewer calories than your body requires to survive for 24 hours, by definition, that's starvation. Do you remember what your metabolic systems do in this situation? Fat metabolism slows down to preserve that vital resource, and you start breaking down your muscle. So people who are trying to lose weight, who go on highly restrictive, very low-calorie diets, are sabotaging themselves. Yes, they will lose weight doing that, but they will lose muscle, which is never the goal. Jonathan?
This is for basal or resting?
This is resting. I'm going to get to basal in a minute. So the trick kind of with weight loss, fat loss specifically, is you need to be taking in above this number and still be at a deficit. So it's very helpful to have an idea of what this number is. Okay? Calculate your own. All you need is your weight.
Yeah, I'm not either.
Okay, everybody get their number? Okay, this number is your resting metabolic rate. Number of calories your body will burn if it stays at rest for 24 hours. Most people will be somewhere in this range, 1,500 to 1,800 calories. If you are below this range, you're probably a very small person. If you're above this range, you're probably a larger person. This is an average range, which is why this average 150.
Oh.
So my phone is on Do Not Disturb, but my kids can
Can't
break
get
through
through.
that. He's asking for money.
I'm gonna get your hot hair.
Classic mom.